Welcome to a briefing on the accreditation of ESP in October 2021. We're going to be accredited according to EAB, the Washington Accord, and as part of this accreditation we will be looking at a number of criteria, but the most important ones that I want to talk about today with you are the module learning outcomes, MLOs, the student learning outcomes, SLOs, and the program educational objectives. Now, what are these? Well, the MLOs are module learning outcomes that you should possess after every module that you take with ESP. So at the end of every module, you will have a set of module learning outcomes. And all of these module learning outcomes for the modules that you take, they will contribute to the student learning outcomes, given in blue here, the SLOs, and these are the attributes, skills, and attitude you should possess at graduation, at the day that you graduate from ESP. Now, the program educational objectives are the skills, attributes, and knowledge you should possess and have achieved around 4 to 5 years after graduation in your professional life. So you can see that the module learning outcomes occur on a semester basis after every module, and all together during your journey in ESP, all the MLOs, they lead over to the student learning outcomes, and the student learning outcomes then in turn prepare you to achieve the PEOs around 4 to 5 years after graduation. And the way that we assess that you have achieved the MLOs, the SLOs, and the PEOs for the engineering science program is through this circle that I've shown here. So it's a continuous assessment evaluation that is ongoing, it never stops. And what we do is we look at the MLOs, the SLOs, and the PEOs. We collect data. We have a number of sources, surveys, direct and indirect assessments to find enough data. We evaluate the data and we see whether there's a need to improve or implement changes in our MLOs, SLOs, and PEOs. And I'm going to give an example of that later on after I have gone through the student learning outcomes and the program educational objectives for the engineering science program. What are the student learning outcomes? Well, the first SLO, first student learning outcome, is engineering knowledge, for you to be able to apply knowledge in mathematics, natural science, engineering fundamentals to solve complex problems. Problem analysis is SLO2, our second student learning outcome. In short, for you to be able to identify, formulate, and research literature to reach substantiated conclusions when it comes to problems that you need to solve. SLO3 is design and develop solutions, essentially for you to be able to design solutions for complex engineering problems that meet the specified needs within the context of the problem that you're looking at. Investigation, for you to be able to conduct investigations of complex problems using research-based knowledge and different research methods here. Modern tool usage, SLO5, for you to be able to use modern software, IT tools, computers, and so forth to achieve, to be able to investigate, to design and solve problems and so forth. The engineering society is our SLO6. Whenever you solve a problem, whenever you reason and do something, you should be aware of society, health, safety, legal and cultural issues when you practice as an engineer. Our SLO7 is environment and sustainability. Again, when you carry out when you do an engineering solution, you should be able to see what the impact of that solution is on society and environment. And for it to be sustainable is a key part here. Ethics, for you to be able to apply ethical principles and commit to professional ethics as a practicing engineer. You should be able to work individually as well as in a team. That's our SLO9. And I always say that working in a team, even when you're a leader, you should be able to step up and step down depending on the problem that you're trying to solve. Communication is SLO10, for you to be able to communicate effectively both in written as well as in verbal form. Very important. Once you have a solution, you need to be able to communicate that to different stakeholders in a language that they can understand and appreciate. SLO11, project management and finance. important to have a bit of knowledge and understanding of engineering management principles, economic decision making there, to manage a project. And finally, lifelong learning, SLO 12. Recognize the need for and have the preparation ability to engage in independent and lifelong learning. And what we do is we try to take the module learning outcomes and the way we teach different modules to ensure that we bring all of those module learning outcomes together into these student learning outcomes. So complex problems, for example, is something that you will definitely encounter in our open-ended design modules. There is going to be individual and teamwork sprinkled across assignments and projects, more or less all modules that have a project. These are the student learning outcomes. Again, these are the learning outcomes that you should have at the day of graduation. I mentioned complex problem, and it's so important that we talk a little bit about what a complex problem is, because many of these SLOs are anchored in the context of a complex problem. For example, if you solve a problem, we want you to be able to solve complex problems, not only simple problems. We want you to be able to engage individually as well as in a team to solve complex problems. We want you to be able to communicate complex problems. So what do we mean with a complex problem? And this is what EAB says. So if we look at complex problems, they possess certain attributes as well as require certain professional competencies. Let me go through these in brief. We're going to have all of this on our webpage. A complex problem requires depth of knowledge. You need in-depth engineering knowledge, fundamentals to solve problems. There could be a range of conflicting requirements, typically between a technical solution and the financial aspects that are conflicting with each other. There should be a need for a depth of analysis. No obvious solution. Again, the open-ended nature of our design projects and some of our assignments, for example, they could require abstract thinking, originality to formulate a solution or carry out analysis. In terms of familiarity of issues, there should be issues there in a complex problem that you haven't perhaps encountered before. And that's what to me makes complex problems interesting. You're always learning something new, you're encountering new situations, and you have to adapt accordingly. Extent of applicable codes. Here, what are the standards and codes required for this problem? Yeah. Extent of stakeholder involvement and conflicting requirements. I already touched upon this. It should involve diverse groups of stakeholders, and again, I can see technical solutions conflicting with financial, so different stakeholders would then have this kind of conflicting requirements. There should be an interdependence inherent in complex problems. And what do we mean with that? Well, high-level problems include many components. So what I like to say is a complex problem, typically what you want to do is you want to divide and conquer it, break it into smaller problems until you are at a stage that you can solve the small problems, and together all of these sub-problems, together you can use them to solve the overall complex problem itself. So that it's typically many components and is oftentimes multidisciplinary. And again, this is something that we do in engineering science. We are inherently multidisciplinary and cross-disciplinary. In terms of professional competencies required for complex problems, there should be consequences. When you solve a complex problem, typically there are consequences to your solutions within a given context. There should be some form of judgment in your decision making. You have to make decisions. You have all these conflicting requirements. You have different stakeholders. You may have different solutions as well, different engineering solutions, and you have to make a decision. And that judgment is important. That's an inherent part of a complex problem. And again, in engineering science, the way we bring across complex problem is first and foremost in our design projects. But you will also find complexity in some of our assignment and projects in other modules as well. And to me, complex problems, open-ended problems are exciting indeed. Now, we've covered the student learning outcomes. Let's talk about program educational objectives. And again, I remind you, these are objectives you should have achieved around 4 to 5 years after graduation, once you have worked actively, professionally in your career out there. And for ESP, they are as follows. the PO1 is naturally engaged in multidisciplinary cutting-edge research and development. I strongly believe in this one because ESP is all about multidisciplinary, interdisciplinary, cross-disciplinary. The second PO is for you to be able to assume leadership positions with confidence. That to me is important in your chosen profession. And again, the way I interpret leadership is not necessarily always leading at the front, but being able to, as I mentioned, step back and work well in a team. Our old PO3 was start up and develop entrepreneurship initiatives, and you can see that I've cancelled this one. And the reason for that is going to become clear when we go to the next slide and I talk about our indirect assessment of the POs and how we have to change and adapt so to make sure that we can deliver on these program educational objectives. And what we have done is we've changed this PO, we've toned it down from starting up, which is not easy. Starting up a new company is not that easy. We've changed it to and toned it down to take innovative and entrepreneurship initiatives. And this is something that is doable, at least much more so than starting up, for example. There. Our next PO is to have proficiency in written, graphical, and oral communication skills. I cannot highlight this enough. Your ability to communicate solutions out there in your company, very, very important for you to be able to represent your company, new products, and so forth. For you to be able to actively serve and contribute to society in a responsible way is one of our program educational objectives. Again, very important that what you do is done in a responsible way. You're aware of ethics, you're aware of sustainability issues, you're aware of impact on society, and all of that comes together in this program educational objective. And the final is have internalized lifelong learning. If you recall, our student learning outcome was also about lifelong learning, but now the difference is that around 4 to 5 years after graduation, we want you to have internalized lifelong learning. And internalized really means that it's part and parcel of your professional working life. You use lifelong learning, you use self-directed learning, always keeping on top of developments and picking up that knowledge, those skills that you need in your professional career. And these are the program educational objectives. Now, very important to stress, you don't have to achieve all of these objectives around 4 to 5 years after graduation. I'm very happy if you have achieved, say, 2, 3, 4 out of these. If you achieve all of them, fantastic. Now, I mentioned here Startup and Develop Entrepreneurship Initiatives. We used to have this as a PO, but we've toned it down. Now, why did we do that? Let me give you one example. We have a number of, as I mentioned, sources where we collect data to ensure that MLOs, SLOs, and POs are met sufficiently well. And here is one example from an alumni survey of POs. And what we do is we survey our alumni roughly 4 to 5 years after graduation, and we ask them, here are our POs. So PO1, naturally engaged in multidisciplinary cutting-edge research, is the first pillar. Second is leadership. Third is startup and develop entrepreneurship initiatives. You see I've circled it in red here. We're going to come back to this pillar soon. We have PO4, which is about communication. PO5, which is about being responsible in what you do. And PO6, which is about internalized lifelong learning. Now, let's look at the collars, and what I want to draw your attention to here are the green and the yellow-orange collars, because those are where our alumni say that they strongly agree that they have met these POs, that they are indeed able to naturally engage, that they are indeed able to assume leadership positions and so forth. Looking at the first column, you can see green and yellow, fantastic, 91% in 2015. Where we had this survey, and again we had a survey in 2020, and we can see that 72%, I'm happy with those numbers. And looking at PO2, you can again see that we have a good chunk of strongly agree and agree. Now we come to PO3, you can see in 2015, we had a good number of alumni who agree that they were able to start up and develop entrepreneurship initiatives. However, 5 years later in 2020, only 34% strongly agree that they have achieved this PO. And that's one of the reasons now why we have evaluated this, and we have decided to tone down, if I go back to the previous slide, from startup and develop entrepreneurship initiatives to take innovative and entrepreneurship initiatives there. And we will assess this new PO in around 4 to 5 years, again, to see whether alumni are able to achieve it. Looking at the third last, so PO 4, 5 and 6 here, you can see that they are overwhelmingly green and yellow. And in particular, this one is fantastic. So happy that our alumni feel that they have internalized lifelong learning, because looking ahead, the way I see the professional careers is really going to be a lifetime of different careers, not a lifetime of one career. So you've got to be nimble and flexible and be able to pick up, as I mentioned, those skills and attributes that you require and knowledge that you require in your professional career. So here you can see an example of how we assess the data and make decisions based on whether we strongly feel that we have achieved the POs or the student learning outcomes. Now, next slide, I want to show you the SLOs. This is a graduate exit survey of SLOs from 2021. And what you see in the columns here are SLO 1 to 12. Remember, we have 12 SLOs. They are on our ESP webpage as well. I want you to read those. Very important. Those are something that you can work towards as you are with ESP. And again, strongly agree and agree. I want to draw your attention to green and this yellow color here. And you find throughout that we have a good proportion of green and yellow, which makes me really happy, because this tells me that our SLOs, that's graduating students, feel that they have met our SLOs, that they agree that they possess these outcomes. Now, for example, looking at SLO 11 here, I see that 30% are neutral, not strongly disagree and disagree. They're not saying that they don't have this SLO 11, but they're sort of neutral. And this now is a flag for me and for us in ESP to look a little bit closer and see that we have enough modules that have enough contents to cover this SLO 11. So now you get a feel for how we in ESP evaluate our module learning outcomes, student learning outcomes, and program educational objectives to ensure that we give you a good education and that what we promise you in terms of outcomes are indeed met. Now, many other metrics that I could show you, but I thought I would bring up one more, and those, I think this one is really important. And we've used data from Ministry of Education Singapore, and these are the average gross starting salaries for ESP students going all the way back to 2010, where our first ESP cohort graduated. And what you can see is I'm contrasting that with the black line. This is the average of the average salary in the faculty engineering NUS. I'm not comparing with other universities and so forth. If you're interested, you can Google and find the graduate surveys done by Ministry of Education, gross starting salaries. It's available out there. But again, coming back to this, we're only looking at faculty engineering NUS. This is the minimum average across all departments. This is the maximum average, and this is the average of the average, if you so will. And so what you can see is, again, the bar is the average gross starting salary for ESP 2010. It was on the low side. You see the dash red line, that's the lowest average salary for any department in faculty engineering. And I believe this year we had a large chunk of students going out and doing further studies, PhD and master, which is why we had this smaller. I'm hypothesizing here. So we can quickly see that in 2011, the salaries jump up and we are very close to the average. He was slightly below, and then we go above, slightly above, we're above. In 2018, our graduating cohort was so small that we didn't have enough statistical power to publish the data. The MOE felt that we cannot publish the data because it lacks statistical power. So 2018 we don't have any assessment. By going to 2019 and 2020, two most recent ones, you can see that ESP has done very well. We're indeed giving now the max. Our graduating students from ESP are commanding the maximum salary in faculty engineering that I've looked at here. So you can see that we are using all kinds of metrics information from across the board to assess that our program, engineering science program, we're able to train and educate our students so that they command good salaries from industry, that they are welcomed by industry. I think I will stop here. Thank you very much for listening. And again, the SLOs, PEOs, you can find them on our webpage. And I really strongly recommend that you read up and check them out when you have the time. Thank you very much for listening.